Hello, this will be lesson 1.1c. So let's get started. Okay, today we're going to be talking about changing non-terminating repeating decimals into fractions. So remember what I told you in the last lesson. A rational number is always able to be written as a fraction, and repeating decimals can be written as fractions. So that's what we're going to be learning today. So all of the numbers we're working with are rational numbers today. So you're going to be able to say, I can change a repeating decimal into a fraction. The standard is at 8ns1. Know that numbers that are not rational are called irrational. We learned that in the last lesson. Understand informally that every number has a decimal expansion. For rational numbers, show that the decimal expansion repeats eventually, and convert a decimal expansion which repeats eventually into a rational number. So we're working on converting those repeating non-terminating decimals. Let's go to the next slide here. First of all, see if you can remember these terms. Think to yourself, what was an integer? We learned that in the last lesson. What's a rational number? What's an irrational number? What's a squared number? What's a square root? What's a perfect square? What's a perfect cube? Be thinking about this. If you can't remember, you need review. Go back and watch lesson 1.1a or lesson 1.1b so that you're clear on what these terms mean. Do you know what a principal square root is? A perfect square, a cubed number, a perfect cube, a terminating decimal, or a non-terminating decimal. You should pause the video at this point and see if you could jot down a little bit of a definition for each of these words so that you're clear on what they are. You're going to have your turn in a moment. You're going to have to match some of these words. So I'll give you a minute to pause and write down what you remember about each of these words. I'll see you back in a second. Okay, hopefully you got a good understanding of these words. So now it's going to be your turn, so give it a try. Welcome back. Okay, did you get those words right? Good for you. Changing decimals into fractions. So you have learned how to change a decimal into a fraction in the last lesson. So 0.75 is equal to 7/500. So if you were to write, let me bring down my little tool here. If you were to write 0.75 as a fraction, you would write 7/500. That's how you read this word, 7/500. So if you remember right, let me just do a quick review for a second here. And if we had some place values, let's put some empty place values here. Oops, I didn't want that to be crooked. Undo and try again. You wanted to make just a few. I'm going to go 4 place values to the right of the decimal. So do you remember what each of these place values is called? I'll actually go one more. Go this way. So we know that these are ones. Hopefully I can get this to fit. We know that these are the tens place. But what is it to the right of the decimal? Well, this is the tenths place with the TH, correct? And I'm going to have to move that over just a little bit so that I can get it to fit right underneath there. Maybe have to abbreviate or something. And then the place after that is called hundredths, correct? And I have to move that over a little bit so that can fit under that spot. And hundredths. And then I'm just going to move over my lines just a little bit, just so that Give a little bit more space to write the next word. And the next one then after hundredths is 10,000. Oops. Correct? Oh, no, just thousands. What am I saying? Just thousands. The next one's 10,000. I'm getting ahead of myself. I just told you the answer. And the last one is 10,000. 10,000. And don't forget there's a TH on the end there. I'm just going to put that one right down here because we ran out of room. And I'll just draw a little arrow pointing to that. So if we went to the left further, we could say ones, tens, and we could go hundreds, thousands, 10,000s, 100,000s, millions, right? We can do the same to the right of the decimal. Tenths, hundreds, thousands, 10,000s. Next would be 100,000s and then millions. So 0.75 would be written, 7 would go here, and the 5 would go here, right? 0.75. So you always read a number. First you read the number, so 75, and then you read the place value it ends up in. So it ended up in hundredths, so you would say 75 hundredths. And then to turn that into a fraction, you just put 75 over 100. I'm going to try another one once. Let's change my color here. Let's do 3, 4, and 7. Remember, they would be all together. I just moved the line over. So 347, how would you read that number? 0.347. Right, it would be 347, and then what place did it land in? It landed in the thousands. So 347,000. You were going to write that as a fraction, then you would write 347 over what number? Right, 1,000. So that's how decimals work when you put them into a fraction. Okay, keeping that in mind, I'm going to clear all these drawings. Move on a little bit here. Okay, so I'm going to reduce my 75 hundredths. So I have to figure out a number on the top and a number on the bottom that I can divide by, the same number, right? So I happen to know that 25 is going to divide into 75 and 25 is going to divide into 100 because I'm thinking of my quarters, and I know 4 quarters equal 100 cents or $1. So I'm going to divide the top and the bottom by 25. And consequently, why can I do this? Because 25 over 25 is really the same as 1, right? Any number over itself is 1. So I am really just dividing the fraction by 1. So I'm just renaming it is what I'm doing. Reducing, renaming. So when I divide 75 by 25, I get 3 on top. I divide 100 by 25, I get 4 on the bottom. So 0.75 is actually equal to 3/4. So think about 3/4. That's 75 cents, right? That's 3/4 of $1. Okay? How could you change a repeating decimal into a fraction? We know it's pretty easy to change one of these non-repeating, these terminating decimals into a fraction, but how could we change a repeating decimal into a fraction? I'm going to do one more non-repeating decimal. I'll do this up for a second and take a little space here. Let's do 0.426. How would I change that into a fraction? Well, think about our place value. Tenths, hundredths, thousands, right? So we would have 426 over 1,000. And then I would have to reduce it. Well, I would imagine that I could reduce by 2, probably something bigger. Oops. But let's start with 2. You can always start with 2 if you have 2 evens, right? So 426 divided by 2 is going to be 2 And 1,000 divided by 2, I bet you know that. Exactly, 500. 500 plus 500 equals 1,000. And now I can't reduce this number here, this fraction, any further than 213 over 500 because nothing goes into 213 except 213 and 1. It is a prime number. So that is as low as I can reduce 426 into. So 426 is equivalent to 213,500. Okay, now that I've said that, let's try some repeating decimals. Let's see what we do. The next slide. Okay, we're going to change 0.37 repeating into a fraction. Let's take a look at that. How would you change 0.37 repeating into a fraction? When I say 0.37 repeating, what do I mean by that? I mean 0.37, and the bar is over the 3 and the 7. That means 3 and 7 repeat, 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 repeat. I'm going to go further. 3, 7, 3, 7, 3, 7, 3, 7, 3, 7, 3, 7, 3, 7, dot, 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 dot. Meaning that you could forever go on into eternity writing 0.373737. So 0.37 repeating means that the 3 and the 7 will repeat in that pattern forever and ever. So how are we going to change that number into a fraction? Stay with me here. So step 1 is going to be set x equal to the decimal number you want to change. So we want to change 0.37 repeating. So we're going to say x equals 0.3737 dot, 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 meaning that it would go on forever. So now we know what x equals. Step 2, 0.37 has 2 repeating digits, right? A 3 and a 7. The pattern is 2 digits repeat, 37, 37, 37. So you're going to multiply both sides of the equation above by 100. Why did I pick 100? Because 100 has 2 zeros and 0.37 has 2 repeating decimals. So let's multiply both sides by 100. So if I multiply 100 times x, I will get 100x. But what's going to happen if I multiply 100 times 0.3737? So when you multiply a number by 100, the decimal moves 2 places to the right. Get a different color here. So my point here, my decimal point, is going to move 2 places to the right. So don't count the first spot. You got to count the jump. 1 spot, 2 spots. I'm going to move my decimal right there. Now the number is going to become 37.37373737, repeating forever and ever, right? Now our goal here is to get this 0.37 repeating to become a fraction, because we know that a fraction is a rational number, and we know that 0.37 repeating is going to be a rational number. So let's see what happens when we multiply by 100. So now we have, and you'll see that right here, we have moved the decimal 2 places to the right here. It is now 37.3737373737, repeating. And the left side is times 100 and x, right? 100x is 100 times x, as far as we can take that one. Okay, let's continue. Step 4 is to subtract x from both sides, but substitute the repeating decimal for x on the right side. So what I'm saying here is I'm going to subtract x from this side, and I'm going to subtract x from that side. But remember, up in step 1, we said that x equals 0.3737. So instead of putting an x in the spot right here, I'm going to put 0.3737. So I'm going to actually erase my x, and in place of it, I'm going to put 0.37. I'm actually going to erase my, well, I can put it, I think. I'm going to put 0.37. Trying to line this up nice and neatly. 37 dot dot dot. I could keep writing 37 and 37s if I wanted to. But why did I do that? Remember that 0.37 was x. So I actually did the same thing to both sides. Remember, you always have to do the same thing to both sides of an equation. We put minus x here. We put minus x here, but we changed the x. We substituted in 0.3737. And then we just subtract. So what I'm doing now is I have on the left side, I have 100x minus x. Now remember, an x, a variable, actually has an imaginary number 1 in front of it. So I'll try to write a number 1 there. See, that looks like a 1. So now I really have 100 minus 1x. What is 100 minus 1x? Exactly, it is 99x, right? The x just stays with it. So now we have 99x on the left, and on the right, what are we going to have? Well, we have 37.3737 minus 0.3737. Well, let's see what happens. 7 minus 7 is 0. 3 minus 3 is 0. 7 minus 7 is 0. 3 minus 3 is 0. Decimal point, 37. So I basically have 37.0000, and if I were to put more 37s going to the right, they would all be zeros. So technically, I could just erase the zeros after the 37 because 37.000 is really just 37. So now I have an equation that I just need to solve. So I have to solve for x because we want to get x equal to a fraction. What do I have to do to get x by itself? Let's use a different color again. So I'm actually going to take that last step here, or that fourth step anyways, and hide it for the moment so that I have a little bit of space here to finish my equation. So now what I have, different color, 99x equals 37. To get rid of the 99 so that x is all by itself, I divide by the coefficient in front of the x. Coefficient just means number in front of the x in layman's terms. 99, and I have to do the same thing to both sides. I'm going to divide the other side by 99. And notice what happens when I divide by 99 over 99. The 99s become 1, right? Where they cross each other out, they cancel each other out, and I'm left with just x. And what is x equal? I have made a fraction out of 0.3737 repeating. I now have 37 over 99. That is a fraction. If you take your calculator and you divide 37 divided by 99, see what you get. Pause the video, see what you get when you divide 37 by 99. Okay, did you get it? Did you get 0.3737? And your calculator is just going to keep going until it has no more spots on the display, and then it's probably going to just cut it off at a certain point, even though we know that it repeats forever and ever. So notice how we have made 37/99 is the equivalent fraction to 0.37 repeating. I'm going to clear my drawings because I actually did this for you with the computer. So let's see, done again. So we're going to subtract both sides by x. Remember, we are substituting in 0.3737 for the x right here. Okay. And when we do that, subtraction, we get 99x equals 37. Okay, so on the next page, I show you how to finish the job. Step 5, divide both sides by the coefficient in front of x, which we did. It's 99. The other one gets divided by 99. Step 6, cancel the 99s on the left side. Reduce the fraction if necessary. Well, 37 99s cannot be reduced. Let's cross off our 99s. We're left with x equaling 37.99, and that's as low as that fraction will reduce to. There's our answer. Step 7, what we did, check by using a calculator and dividing the numerator by the denominator. So we divided 37 by 99. Hopefully you paused the video and tried that. Your calculator should have shown you it was 0.3737 repeating. And now we are going to try another one. Just moving my toolbar here. So let's do 0.5 repeating and turn that into a fraction. So what's our first step? Set x equal to the decimal number you want to change. Okay, so let's do that on the right here. I'm going to change back to red color. So x is going to equal 0.5, and it's 0.5 repeating, so I'll just to show you that it's repeating, I'm going to do something like this, and I could keep going, right, forever and ever. I'm just going to go dot, 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 dot. It goes on forever. So step 2, 0.5 has how many repeating decimals? 1, right? The 5 is the only part that repeats. So I'm going to multiply both sides of the equation by 10, because 10 has 1 0 in it, and 0.5 has 1 repeating decimal. I'm just going to put 10. Last time we had 2 repeating decimals, right? We had 3737. We multiplied by 100. Now we only have 1 repeating decimal, so we're going to multiply by 10. If we had 3 repeating decimals, what number would we multiply by? Exactly, 1,000, because 1,000 has 3 zeros in it. Okay, next step. When you multiply a number by 10, the decimal moves 1 place to the right. Not 2, but 1 place to the right. So we're going to end up with moving our decimal 1 place to the right. It's going to go right here. So we're going to end up with 10x, because 10 times x is 10x, equals, what does it equal? Move your decimal 1 to the right. Right, 5.55, and I could keep going, 5, and another 5, and another one, but I'll just go dot, dot, dot. Okay. Now, step 4, anybody remember what it is? What do we have to do next? Subtract x from both sides, but substitute the repeating decimal for x on the right side. So let's first subtract x. Look, actually, I'm going to use red now so we know that we're doing something different here. I'm going to subtract x from this side of the equals in there, and I'm going to subtract x from that side of the equals. But remember, I am going to substitute this number, 0.5555, for x. And I can do that. So I'm going to clear, I'll just undo this, get rid of my x, and instead I'm going to put 0.55. I could sing again if you want me to. 5. I don't think anybody does, right? Dot, 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 dot. Okay, now I'm going to subtract. I know you have a weird teacher. I agree. Okay, Now subtract. Remember that minus x is really minus, and I'll put it in blue, minus 1x, right? It's the same as a 1, right? We just don't show it. So now we have 10x minus 1x. What does that give us? 9x. 10 minus 1 is 9. That's been like first grade, right? 10 minus 1 is 9. And then we just have a little partner along now, an x. So by the time you get to 8th grade, you just have to add those extra letters there instead. Now, what is 5.555 minus 0.5555? Well, 5 minus 5 is 0. 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 Put my decimal point. Remember, keep the decimals, line up the dot, and give it all you got. 5 minus nothing is 5. 9x equals 5.00000000. We can get rid of the zeros because it's just 5. So let's erase our zeros. 9x equals 5. Step 5 is divide both sides by the coefficient in front of x. In our case, this time, we are dividing both sides by 9 because we have a 9 there this time. Why do we have a 9? Because we only had one repeating decimal, the 5, one repeating digit. So now I can cancel out my 9s, and I'll be left with just x equals 5 9ths. Now remember, the goal of this lesson is to get my repeating, non-terminating, rational decimal number equal to a fraction. So I have just made 0.5 repeating into a fraction. So step 6, cancel the 9s on the left. We did that. Get that bottom thing to go away there. Should go away in a minute. Yep. Cancel the 9s on the left side and reduce. Well, there's nothing to reduce. 5 9ths is as low as it goes. And then step 7 is to check with a calculator. So what are we going to do to check? We're going to divide 5 by 9. So 5 divided by 9 equals, pause the video, give it a try with your calculator. What's 5 divided by 9? Did you try it? It should be on your calculator, 0.555555 repeating, and your display is probably going to end at some point. It's probably going to say 0.55556. Probably going to give you a 6 at the end because it's going to round the last digit up. Some calculators are going to do that. So that is how you change a repeating decimal into a fraction. Okay, I'm going to clear all of this. If you need to re-watch parts of that, you can go back and do that. I'm going to give you a chance to give it a try. So go right ahead, give it a try, and I'll see you back in a minute. How did you do? Tough stuff, right? I think you guys are doing great. Okay, are you ready for the shortcut? I'm not going to leave you with this long version, but I wanted to show you how it's done so that you could understand where and why and how everything is working out, because math is all about logic and reasoning. So here is the shortcut. We're going to change 0.57 into a fraction. Now we know how to do that using the long method, right? We're going to set x equal to 0.57, and then we are going to multiply both sides by 100, right? And then we are going to subtract x from both sides. So one side on the left, we subtract 1x. On the right side, we're going to subtract 0.5757. We're going to end up getting 99x equals 57, right? And then we're going to divide both sides by 99. And we're going to get 57/99. I know I just said that quickly, but you can go back and watch the first two to see how it's done. Here's the shortcut. We're going to move the decimal in the repeating digit to the right, the number of repeating digits, and drop the remaining repeating digit. So, for example, we have 0.57 as it stands right now. And we know that the 5 and the 7 are going to go on forever and ever, dot, 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 dot. We are going to move our decimal how many places to the right? Well, we have 2 digits that repeat, a 5 and a 7, so we're going to go 1, 2 digits to the right. That's the same as multiplying by 100 using the long method, correct? Yes. So now we have our new number. Put your new number over 9 if you are having 1 repeating digit, 99 if you have 2 repeating digits, 999 if you have 3 repeating digits. And don't forget, we are dropping, I have to put that in there for you guys. We are dropping, once we move our decimal, any 5757s, if there were more written here, any 57s after it. That's like subtracting in our long method. So now we are just left with 57. And now we're going to put it over. Let's see what the step 2 says. Put your new number over 9 if you have 1 repeating digit, 99 if you have 2 repeating digits, 999 if you have 3 repeating digits, and we could say 9,999 if we have 4 repeating digits, etc. So how many repeating digits did we have? We had 2, right? So we're going to put it over 99. There is our shortcut method. Then we can check with the calculator. 57 divided by 99 should equal 0.57 repeating. If we needed to reduce the fraction, we could do so. 57/99 does not need reducing. Nothing will reduce in that number. So, and then we can do our check with our calculator. So pause the video, type in 57 divided by 99, see if you get 57575757 repeating. Did you do it? Okay. So you should end up on your calculator display, might end up saying 0.57575757 and finally 58 because it'll round up on the last digit because it runs out of room. Okay, let's clear our drawings. So let's try the shortcut method to change 825 thousandths into a fraction using the shortcut method. Step 1, move your decimal to the right on the repeating decimal, the number of repeating digits that you have, and drop the remaining repeating digits. So we have 3 repeating digits, right? The bar here is over 8, 2, and 5. So that means our number is 8.825, 8, 2, 5, 8, 2, 5, repeating. So forever and ever. So dot, 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 dot. So we're going to move our decimal. How many places to the right this time? How many numbers repeat? 3, right? 3 numbers repeat, 8, 2, and 5. So 1 spot, 2 spots, 3 spots. We're going to move it right here. Our new number, we're going to drop all the numbers after that. So we'll be left with 825, right? Now, we're going to put our new number over 9 if we have 1 repeating digit, 99 if we have 2 repeating digits, 999 if we have 3 repeating digits. How many repeating digits did we have? Right, 3. So we're going to put our answer over 9, 9, 9. And this one actually, I think, can be reduced. So remember that step 3 is to reduce if you can. We didn't have any so far that needed reducing, but I believe we can reduce this one. So let us divide 825 by 3. and 999 by 3, and I think that'll reduce it. The way I knew that it was a 3 would work is because if you add the digits 8 plus 2 plus 5, you get 15, right? 15 evenly divides by 3, so I know that the whole number 825 will divide by 3. That's kind of a shortcut to knowing what numbers divide by 3. You just add up the sum of the digits in the number. That sum, if that's divisible by 3, the whole number is divisible by 3. So also with 9, so if I add 9 plus 9 plus 9, I get 27, and I know that 27 is divisible by 3. So I know that 999 is divisible by 3. So let's just do long division to divide 825 by 3. And remember, I don't want you using your calculator yet in the first half of the year. So I would like you to be practicing these long division skills. How many 3's go into 8? 2, right? 2 times 3 is 6. 8 minus 6 is 2. Bring down the 2. How many 3's go into 22? 7, right? 3 times 7 is 21. Bad 2, but 21. And 22 minus 21 is 1. And then I bring down my 5. 3 goes into 15 5 times, right? And 3 times 15 is 15, and 15 minus 15 is going to give me a remainder of 0. I'm done. I've divided. So 825 divided by 3 is equal to 275 on the top. 999 divided by 3, you could use long division, but I think it's a pretty easy one to see that the 3 will go into 9, 9, and 9, 3, 3, and 3 times, right? So now let's see, can we divide by another 3? Well, let's add up the digits. 2 plus 7 is 9. 9 plus 5 is 14. 14 does not evenly divide by 3, so that's as far as we can go. So 275 over 333 has been reduced, is the reduced fraction from 825,999. So on a test question, you're going to have to make sure that you reduce if you need to. So let's check it with our calculator. We should be able to divide 275 by 333, and we should get 0.825 repeating. Give it a try, pause the video. You could also try dividing 825 by 999. You should also get 0.825 repeating. Okay, pause the video, give it a try. Okay, good. Did you get the answer? Excellent. Okay, oh, gotta clear my screen. Now it is your turn to give the shortcut method a try. Good luck. See you in a minute. Okay, you're back. Homework. Let me put myself back on there. There we are. Homework is going to be page 12 in your math book, numbers 10, 11, and 12. I would like you to use both the long method and the shortcut method. I want you to give both methods a try. And then I would also like you to do IXL rational numbers, D4 it's called, converting between decimals and fractions or mixed numbers. And then I have extra credit on page 13 of your math book, number 26. It's worth 5 bonus points if you get it correct. So I want you to give that a try as well. Definitely try it. Can't hurt to try. You can't get points off for not getting it correct. It's extra credit. So I believe that we are now finished. So we will see you shortly. Have a good day.